and welcome to question 1, parts A and B of the Spring 2026 61A final. Let's jump right into it. So these two questions for the first part A are orders of growth questions. So for example, the first part, we are gluing sequences of pennies and dimes to make bookmarks. We don't want to go over budget, so we write the code to count the number of distinct bookmarks you can make for a bookmark that has n cents in it. So we see here that if we're just looking at the function, these two things take constant time, right? Because we're just checking a condition that doesn't have any function calls or anything. It's just arithmetic. And then we're just returning a constant value. So that takes constant time. So the only thing that we need to focus on are these two recursive calls. When you have two recursive calls like this, in the specific format, it is tree recursion. And remember that basically for every call, we're going to have two more calls. So if we call this A and call this B, for every call, we're going to have an A and a B call, right? And this structure is growing exponentially because it's tree recursion. So this has an exponential order of growth. Great. For this next part, we see that the following code takes in data as a list. So you know that data is a list, and then we need to say assume append takes constant time, right? So these operations are taking constant time. So because those appends take constant time, what we need to look at is the two for loops there. So when a for loop, when the thing you're iterating through in the for loop is a range of a constant value, so like 1,000 or even 1,000,000 or 1, that means that the for loop takes constant time. So it'd be constant time. And then it's for D in data, right? So we're going through every single element in data. And when you're going through every single element of a list, that is linear time. And then to get the result, you're going to do n for the linear time times 1 for the constant time, right? Because it's a nested for loop. And then you're going to get n as your result. So the resulting order of growth is linear. Okay, and that is all for part A. Let's go on to part B. So we are assuming the following code has been executed. There isn't any like creation of the classes or anything. We're just like initializing them. We haven't like created any instances. So let's start. We see that we are creating a B object. So inside B, we have this B variable 30, but I'm not going to write that because that's a variable that's shared between all B variables. So if we ever needed to make another one, I wouldn't want to have to recopy the Y value later because it might get confusing. But what we can copy is the self.x equals 5 in the initializer. So x is 5. Great. And then we're calling .f. So because this is a B object, we look in the B class. Is there an f function? Nope. That means we look in the superclass, which is A. And it says that we define f of self as returning self.x plus self.y. So we have self.x for our B value, right? And then to find self.y, we go back to looking in the B class. And because there's no like y variable here, we're just able to get this y variable right there. So our result is 35. Okay, and then for this next part, we're making a C object. We'll look in the C initializer where we set x is equal to self.x for our C instance to be 0. And then we're calling the super initializer, which means that we look at B, which is C's superclass. We see that we're setting self.x equal to 5, which means that this is now 5. And then we're setting self.y equals to self.x plus self.y, right? But we don't have a self.y in C, right? So that means that we look at B to get self.y, which is 30. So it's going to be self.y equals self.x, which is 5 plus 30. So y is set to 35. And then finally, we still need to call f, right, on this new C instance. So we look in class C for an f function. We don't find it. So that means that we look in B. There's no f function. So that means that we move to A. And we return self.x plus self.y. Sorry, which means that we return 5 plus 35, which is 40. And that's all for question 1, parts A and B. I hope this video was helpful for you.